What's up, guys? Today I'm doing LeetCode weekly contest 198, and I'd say hopefully solve all 4 problems within 10 or 20 minutes. Hopefully not like last time. Last time I had like 6 penalties on the last problem, which was not good. Okay, so start with the answer. And while num bottles is positive, we add num bottles to answer, and then we divide by the exchange rate. Which is okay. We need an adjacency list. Let's check the code for this. 13, 19, 62. Okay, something's wrong here. This will be the number of empty, so oh wait. Okay, number empty is just our bottles mod number of exchange. And then this is a new number of empty. Let's try this again. So here, let's create the adjacency list. There's the answer array. Then we also have count array of length 26, and we do a DFS on tree and return the answer. Time limit exceeded. As long as this is greater than or equal to num. If num bottles is positive or number of bottles plus number, this is greater than or equal to the exchange rate, then you could probably do it. DFS flat set node 0. If b is not equal to the parent, then we do DFS. The last count before entering the subtree is of u. The answer for u is just this minus the count. Also, we add 1 to this Okay, let's use examples. 13, 19, 6, 2. Hopefully this is correct. Just checking the... Yeah, it looks correct. Accepted. Accepted, okay. Okay, we find all 26 ranges first. Like, store a position array of all the indices. And while two ranges like intersect, we basically just keep merging them until none of the ranges intersects. So the first one and the last occurrence. Have a variable called change. So while like there is still a change, then we keep continuing to merge. Our answer array will be built based on the array of ranges. Let's take the substring starting from A0 and run on. The length is this. I is equal to j, then we continue. Otherwise, we check if start of the second is within the first interval, then we merge I and j. Erase them from the list, and then we add the merged interval back into the list. And the new endpoint is just the maximum of the two previous endpoints. And yeah, this looks good. What does this do? Target is okay. So basically, we find the AND value of an entire subarray, and we want it to be as close to target as possible. Let's just check this first, runtime error. What happened? I'll just do this. Wait, actually, I'll just find the index inside. Hopefully it works. fccd. Oh wait, I forgot to substitute in A and B. So actually they're only like, what's key array? There are only like 20 different AND values, possible AND values you could get. It's a set of all possible values you can get. And then answer set to this. Let's check this. DFADD. This is not correct either. Why is everything merged? Oh, that's because, okay, I need an and, not or. New set. So new set starts with the single element. And then also for everything in the old set, we'll insert A and the new element into the set. For everything in new set, we update the value. A minus target, CCCF. Find the maximum number of substrings. Oh, might not want to merge them. 2999. Okay, this probably works. This I need to think. I just got accepted. Wait, this isn't even correct. Answer. Okay, am I missing something here? if some character like completely contains another character, then we just probably just don't even add it inside. Okay, so basically check if it completely contains another character. CCCEF. Okay, it seems to work on samples. I'll hope it works in general, but which it doesn't. Output. Oh, right. So if it does not contain. Okay, so if this range does not work on PI, search for the end and the beginning and the end inside of. Okay. Wrong answer again. Okay, I need to rethink this. You should probably create a graph where if we take it's even this complicated. Okay, I'm gonna look at the rankings and yeah, people are not solving. Yeah, but my algorithm basically does what SCC does, right? A contains oh, it doesn't. Okay, so which is weird. Okay. if which means if we take okay, this means if we take J, we must take A as well. If we take J, we must take A as well. Yeah, because there's an occurrence of I inside the range for J. And then if it's not visited, I'll call it DFS1. And then there's stack. Actually, I don't need to do okay, I actually know like which ranges I should add. Let's try to get to, if we can get to J without J getting to the I, then something is wrong. So basically I can do Floyd-Warshall first. If we can get from I to J but not J to I, then this is bad. And only if it's okay that we add it into the ranges. Okay, so let's test run. Expected E and C. Okay, something didn't work. And yeah, this is weird. Oh, okay. But we can't get from J to I. ABAC. Okay, let's see. EFCCC. Because I really expected a greedy algorithm and not like strongly connected components. So, like, and this is labeled as a medium. Like, yeah, did not expect strongly connected components, so that messed me up a bit. Yeah, so I'm the first person to finish all the problems in 25 minutes, but my penalty is not so good. So it could be very possible that someone beats me in the end. I don't know. Okay, for now I'll just go over all the questions and then I'll see what the final standings are. Like after 10 minutes have passed, I can be sure that I'll be first if nobody else is above me, because I got like 10 minutes of penalty time. Okay, so for problem 1, you do a simulation based on the number of full bottles that you have, which is in num bottles, and number of empty bottles that you have, which I store in NE. And then while you still have full bottles left to drink, or you have enough empty bottles left to change for, then actually I don't think you need this condition. Yeah, but anyways, if you still have like bottles you can use, then you drink all the full bottles, and then in the end you get like this many empty bottles, num bottles plus the number of full bottles in the beginning plus the number of empty bottles in the end. So then you exchange those, like given the exchange rate, like you can exchange these for full bottles, but then the remaining ones, they will still become empty bottles. So we store that in NE2 first, and then after we calculate this, we store NE2 back in NE, and then that's like one iteration. And to be honest, I could just you could probably do a simpler sort of loop, because the constraints are very low. They're only like 100, but I guess this will work for like higher constraints as well, even though I don't know exactly how to prove it. Anyways, the second one. Alright, so you build a tree. You get an adjacency list, and then L stores the labels, and then answer is the list of the answers. And then I start DFS from the root. Okay, so C here stores for each of the 26 characters, how many times I've seen them so far in like any DFS. So LC stores this count before I enter the subtree, and then I have a plus here because like when I visit this node, like the count should increase, and then I visit all nodes in subtree with like this recursive calls. Then in the end, in order to find the number of nodes with the same label inside the subtree, I take the total number of labels of this type I've seen so far minus the labels that I've seen before the subtree, and that'll give me the labels which I've seen inside this current subtree, and that'll be the answer. Okay, so for this problem, so first, you can basically get 26 ranges. Each range is like the first occurrence of a character and the last occurrence of a character. And then you have some constraints. So for each range, if it, like in this range for A, if you contain like B and D, then we'll create nodes for each character. Then I just mean that if we choose A, then we have to choose. If we choose a node, then we also have to choose the nodes that point to it. And this is true because if we ever have at least one occurrence, then we need to take the full range. So if you build this graph of 26 characters, you can compress it with strongly connected components, and then into its strongly connected components, then you get a directed acyclic graph. Now the answer will be, you want the maximum number of substrings. So basically the maximum number of merged ranges. And then we want the minimum total length. So in this like directed acyclic graph, first off, notice that like you can prove that like it's impossible for two nodes to go into like one node. So in the end, like you get a sort of like tree structure. And then also, since like if we take a component, we must take the component like that points out. That means we basically take subtrees of this tree. So basically taking subtrees of this tree that don't overlap. And then since we want the maximum number of subtrees, that means we should take the leaves. And then this also satisfies the minimum total length requirement, because you consider we have two ways to take 3 subtrees. We could either take it like this, or we could take these 3 leaves. But then taking the leaves, like if we take like this extra node here, it's still a subtree, but then like we are taking extra characters, which is not good. So in the end, we're basically, these leaves at the bottom, they are nodes such that for each node inside like this leaf, if I can reach, like for each node I in this like component leaf, if I can reach J, then it's guaranteed that J is also in this component, so J can reach I. So you basically find these characters such that, like, basically find these characters I, such that if I can reach some character J, then J must be able to reach I. Those are the ranges that we want. So after we find those ranges, like we just basically brute force like merge them. Like while 2 of the ranges are like intersecting, we merge them. Okay, so as for the code, basically here I constructed adjacency list of the graph, and then I find if there's occurrence of like B, for example, by binary searching like inside the positions array, like from the start to the end, to see if there's an occurrence of B within this range. And I use lower bound in C++. After I create this adjacency list, there are multiple ways you can find these things, but I used a more complex algorithm called Floyd-Warshall, which looks simple, but it's a bit harder to understand. But anyways, now like after this algorithm, adjacent ij now stores if it's possible to get from I to j using some path. So now we go through all like characters I, and then if there exists a character j such that we can go from I to j but not from j to I, then we don't want to include character I in our answer. And then otherwise, if we see that I is okay, then we add it to the list of ranges. Basically just take the first character, the index of the first character, and the index of the last character. And then lastly, we have this like double for loop here to see if, check each pair, and if there's some like intersection, then we basically remove them from the list and then we merge them. And we do this again until like there are no changes left. After that, we convert our ranges into like actual strings. Yeah, this one, I don't know why this is a medium, but in the last one, if you notice the code here, it's basically just this function returns the bitwise AND values of all value in the array from L to R. So one important observation here is that there are at most n log max a of I, basically the maximum value in the array. There are at most like this many values for this function. So if we can find all of these values, it's actually not too many. Then we can check each of them against the target. This is what I do here. So I check each of them gets the target, and then I update the answer. And how we actually find those values is actually pretty simple. We keep a set, we iterate through I, and then say this is I. Then we'll have a set which contains all possible, the distinct possible values for any subarray that ends at I. And then we iterate over these subarrays. And after that, given these values, we update them for I plus 1. And then we do the same thing for the new subarrays, which end at I plus 1. So initially, like, there are no subarrays at all. And then this set ns is the new set. So one subarray is just the element I itself, and it has an end value of just that element. But then we also need to add the subarrays which end at I, which have a length greater than 1. And to do that, we iterate over the previous set for I minus 1. And then we, in order to find the new AND value, basically just AND the, we take the bitwise AND of the old value with the current, like the new element, to create the AND value of the new subarray. And after this, NS stores like all of the values of the subarray for the new, like for this new end, for all subarrays which end at I. And then we iterate over all these values, update them with the answer, and then we set S equal to NS. And yeah. And the reason why it's like the total number is this is because if you consider for like any and if you fix a specific array subarray and I, then there are only like log of max of a like different values you could have. And this is because if you sort all of these values in order, because these are AND values, this means that like the smallest value must be a subset of this, and then this must be a subset of this. And then you can only have like subsets, elements which are subsets of each other. You can only have this for like at most, since they're like since they're log this many bits, you can have at most like this many bits amount of elements where the elements are all subsets of each other. So yeah, that's the simple, like, that's a straightforward proof for that. And I managed to get first in this interesting round, which is pretty cool. I thought I was screwed here because I thought this would be, if you notice, like, I didn't really think through my solution for problem 1. I was just like, this is probably an easy problem. Like, there will probably not be like that many traps and like whatnot. So like I optimized for speed. So I basically submitted without thinking clearly. And the same thing happened for question 3. I didn't really like think through my solution for 2 times. That's why I got 2 incorrect submissions. And if this was like a contest which I knew would be harder, then I would be more careful with question 3. But I kind of got trolled because LeetCode usually has easy questions, especially for question 3. Question 3 is supposed to be pretty easy, but I see that a lot of people have, I think there are more solves on question 4 than question 3. Anyways, this like took 40 minutes, much longer than I expected. But I hope you still enjoyed this somewhat, if you made it to the end.